Okay, you all got your paper out? Let's earn some marks for the coming exam. We're on question 3. We're on question 3. We're on question 6. Okay. Question 6. Learners made a mini volcano and then we had this dry carbon vinegar. Define the limiting reagent, the one that gets used up first. Okay, determine the limiting reagent in this example. Learners make a mini volcano adding sodium bicarbonate, and they added 10 moles of 0.2 ethanoic acid to 10 grams of sodium hydrogen carbonate. Which one's the limiting reaction? What are we always going to have to do? Convert it to moles. Alright? Did anyone convert it to moles yet? So let's use our formula. This is question 6 of last year's paper. So, what's the formula? Number of moles is concentration times volume for the one, and number of moles is mass over molar mass for the other. So let's work out the vinegar. Ethanoic acid is 10 milliliters. That is the volume. And the concentration is 0.2. 0.2. Okay, so who knows how to convert milliliters to decimeters? Divide by 1,000. Great. Okay, so number of moles is concentration times volume. This volume equals 10 divided by 1,000 decimeters cubed, which comes to 1, 2, 3 equals 0.01 decimeter cubed. Okay, so it's 0.01 times 0.2. I know it's going to be 0, something 2. What is it? 0, 0.2? Double 0.2. Okay. Moles. And then let's do it for the sodium bicarb. We've got 10 grams. So the mass is 10. The molar mass is NaHCO3. Na is what, 23.5? 23? What is sodium? 23? Molar mass. 23. 23 plus 1 plus 12 plus 16 plus 16 plus 16. 23, 24, 46, 56, 62, 78, 88, 94. Is that correct? 84. Okay. So mass is equal to 10 upon 84. What's that come to? Sorry? Comes to? 0.12 moles. Okay, now the ratio in which they combine NaHCO3 combines in the ratio with That's bicarb and vinegar, CH3COOH. The ratio is 1:1 mole. Whoa, I'm afraid I've only got this one that I can find. What we'll do is photograph it and give you one online. Is that okay? Would you be able to get one at home on Google Classroom if I photograph this? Because it just seems like this was the last one. I struggled to find it. Okay. Sorry about that. So these are last year's papers. So, look at that. So which one is going to run out first? This one, which is our vinegar. Okay, so 0,002 is less than 0,12, therefore vinegar is the limiting reagent. Look at it, guys. It's important you know the ratio in which they combine. If they combine 2:1, you'd have to have twice as much of the 2 before it runs out. Okay. Any questions? So that was worth 6 marks, determining the limiting reagent. Calculate the mass of the other substance in excess. Calculate the mass of the other substance in excess. What was left over. That's what it means. So which is the other substance? What's the other substance? So if this is the one, vinegar is going to be used up first. What are we going to be left with? We're going to be left with an excess of bicarb. Okay, so 6.3 bicarb is in excess. Why? Because there is more of it than there is of vinegar. So how will we work out how much was in excess? Sorry? How many moles of vinegar will be, how many moles of bicarb will be used up? They're used up in the ratio of 1:1. So when this one is used up, it will have used up 0,002 of that one. Does that make sense? Yeah. Does that make sense? Yeah. Because if it doesn't make sense, there's something I'd rather show you another way of working it out if you like. It's called a rice table. And this is very popular in matric. You first write your ratios of, let's just see the ratio in which they've written it. They write that vinegar is to bicarb is 1:1. That's ratio, R for ratio. I stands for initial number of moles. So we started with that was the vinegar. Vinegar we started with 0,002 moles. Bicarb we started with 0,12 moles. Okay. I love this. I'm really going to test the hell out of this. I'm kind of infatuated with this at the moment. Okay, what did we end with? Which of these was 0 when it ended? The one that was the limiting reagent. So we ended with 0 of that. I love it, so logical. So how much did we use up of this? How much did we use up in moles? C stands for change. We had that, we ended with naught, so how much did we use up?
All of it.
All of it, which is
0,02.
naught, comma, naught, naught, 2, right? So how much of this did we use up if the ratio they used up is 1:1?
0.7.
Also, naught, comma, naught, naught, 2. We must make sure that this ratio is the same as that ratio. So if we start with that, now some people do this, they put a minus for the reactant. So you take that minus that and you get this answer. You take that minus that, you get that answer. So what's 0,12 minus 0,002?
0,118.
0,118. And there's your answer.
That's easy.
But that's in moles.
So, how do you know the ratio is 1:1?
Balanced reaction. There's a 1 coefficient, a 1 coefficient, a 1 coefficient, a 1 coefficient, a 1 coefficient. Good question. Your ratios come from the balanced equation on the top. Now, if they were asking me about these other ones, I would have included them here, the products, but they're not asking me. Okay, but this is in moles. So how do I go from moles back to weight? So let's go back to weight. So let's say, what formula am I going to use? Number of moles is mass over molar mass. I want the mass. So mass equals number of moles. Now what do I want? Yeah. Number of moles times molar mass. What's the number of moles? 0,118 times what was the molar mass of bicarb? 84. And who's got an answer for what the mass is? How much? 9.9. Lovely. Is left over. There was no other decimals after 9.9? 9.912. You always round it off to the second decimal place. Will you be able to do a problem identical to this in September? Just with different chemicals? You could use the table. Nice. You able to do it?
I still don't understand them.
Okay. Who would like to explain?
So,
Yes.
I have a question. Sorry, I just want to ask something. So, for that question, 6.3, we shouldn't have to like I know the rice table here is will be helpful and everything, but if you think about it and just ask the answers and it's only 30 marks, so what if you just subtracted it
Exactly.
first then?
4 marks.
Oh, so that's also fine.
Yeah.
So yeah.
But I wanted to introduce this rice table because
But it did.
we carry it to matric. And I love this way of doing stoichiometry. What you start with, what you change by, what you end with. It's just so logical. Okay, you can explain which part don't you understand? All of it? Okay, do you know what a limiting reagent is? So, do you know how to convert both of them to moles? You've got your formula. On your BFF, you don't have to worry about the formula. So if it's a liquid, convert it using this formula. If it's a solid, convert it using this formula. Okay. So now you know what a limiting reagent is and you know how to find the number of moles. Then they say determine the limiting reagent of this for 6 moles. So, once we know how many moles, how do we know which one is the limiting reagent? The one with the least moles, but bear in mind the ratio could change. So if this was from the balanced equation, the coefficient in front. Just have a look here at this balanced reaction. What's the invisible number in front? 1. What's the invisible morning number in front there? 1, 1, 1, 1. It must be a balanced equation. Okay. Probably for September, I'm not going to give you a 1:2, but if it's a 1:2, you need twice as much of the 2 as the 1. And then, I can tell you, you're going to need this rice table. Right? To make it less confusing. Okay, then to determine the limiting reaction, we've got to work out how many moles each is, and the one that's least is your limiting. Calculate the mass of the other substance in excess. So now you know you've used up the whole lot of the one, the limiting reagent, which was, in this case, 0.02, ended at 0. So your limiting reagent always ends with 0. But then we also, at the same time, 1:1 used up 0.02 of the bicarb. So then we end that minus that equals, that's how many moles of bicarb we ended with. But they don't want number of moles of bicarb, they want mass of bicarb. So then we convert that moles to mass using the same formula. And we end up with a mass of bicarb. Does that make sense? Yes.
What is 6.3 constants?
9.91 grams.
And with that, I will calculate the mass of the substance in excess.
How did we calculate the mass?
Yes, exactly.
We calculated the number of moles of the one that was in excess, and then we converted it to mass. You look confused. So what did I started with that number of moles, I used up that amount, I ended with that number of moles, and I converted it to mass. And that's how I got my answer 6.3. Are you happy with that? Anyone unhappy? What's your question? Okay, I can understand you're unhappy with that. Anyone unhappy with anything else?
So, say for example, we got question 6 wrong, are you going to 6.2 wrong? Are you going to do positive marking from then on, or are you going to mark everything wrong if you got the answer 6.2 wrong?
Look, being a very positive person, I always do positive marking. If you show you know how to work it out, even if you got a wrong answer after that, then you just get your full marks after that. Because normally I can sit and figure out, okay, you got your method is correct. I can normally see your method is correct. Then you get full marks for that. And then calculate the volume of CO2 produced at STP. Okay, now let's go back to this rice table. And let's put CO2 there. What was our ratio of CO2? 1. 1:1:1:1. But this 1 was produced. So it's plus 1. Whatever is produced is plus, right? Now, what is the amount initially of CO2? Oh, that's such a good question. That is such a good question. How much CO2 did we start off when we had bicarb and vinegar in a bottle? How much CO2 was there to start off with? It's such a good question. Anyone with an answer? So I take for my volcano I take bicarb, I pour it in. I take vinegar, I pour it in. How much carbon dioxide was there to start off with? None. Then it bubbled out of here and started producing CO2. So the answer is 0. But it's important that you get it from now and forever, that you'll always start with no products. So we initially had naught. How much moles of this did we produce? Well done. Except it's not 0,02, it's 0,002. Okay, explain to us why, John.
Because ratio is 1:1. So whatever you use up will be produced.
As much as we use up in moles will be produced in moles. Exactly. Because this is like a formula for baking. If you use up 1 egg and 1 cup of flour, you get 1 waffle. So this is the ratio in which you use them up and produce them. So now we're going to say this was plus that was produced. So how much should we end with? We started at naught, we produced this amount in moles, the same number of moles as the others. So how much do we end with? Plus 0,002 moles. All of this. Okay, so that's how many moles of carbon dioxide we produce. Who doesn't get that?
So can you explain
This one. Okay. So the ratios in this column must be the same as the ratios in that column. So once you've worked out your limiting reagent, that's going to determine how much of that is used up, and that is produced. So that's minus that, plus that. Some people put the minuses in plus. I like it. So we start with no carbon dioxide at the beginning. We produce the same number of moles as we used up into the balanced equation, and with that number of moles. But we're not finished the problem. What do we got to convert that to? Volume. So here's the formula for volume. We know that 1 mole gas occupies 22,4 decimeter cubed. Don't we know that? Did you know that? So that is on your BFF again, and it's just something you must remember. Any gas occupies 22,4. We didn't have 1 molar gas, we had, therefore 0,002 moles of gas occupies, and how would we do it? Now, let's just call the amount X, shall we? I like this. This is some girl taught me this last year, I think it was. At another school. This is how her teachers taught it. If you say 1 times X is always equal to that times that, you just cross multiply. So you say 1X equals 0,002 times 22,4. Did you see what I did? What she said you do. That's how her teacher taught it. So I'm teaching the way she taught me. So I don't have to think that I put that to that. I just cross multiply. And I say 1 times X equals 22,4 times that. And I know my answer is going to come correct. Okay, so what does the answer come to? 0,002
I think I understand.
0.045 meters cubed. If you did the multiplication correct. How do you like that?
Because in every problem you get 1 mole using the formula.
Okay, so the formula is 1 mole of gas always occupies 22,4. Therefore, there's no real formula. This is actually, now that I think about it, there is a formula, but I'm not sure if it's on your data sheet. It goes something like this. Number of moles equals volume over molar volume. And our volume, so therefore you take your number of moles times molar volume. Number of moles times molar volume.
Now, sir, if we just do that, we get our full marks.
Yeah.
We don't need to do that.
Okay, so this is your volume of gas you have over the molar volume. Any questions? Yeah, I forgot about that formula. I'm not just on the data sheet though. Okay, it's on the data sheet.
So,
Yeah,
can you say that out loud, please? Because I can't see what it is.
just say that again.
Like when you read it close.
It's on your data sheet.
This
No, so.
or this, the formula.
Please. What did you say?
Number of moles equals volume over molar volume.
Thank you, sir.
And the molar volume is always 22,4, which is equal to, this is always equal to 22,4.
So what if I think that's always 22.4?
Molar volume of a gas is always 22,4. Who can explain to me what it means by molar volume? How many of these milk bottles do I have to have full of gas to get 1 mole of any gas? This is a 2-liter milk bottle. And a liter is a decimeter cubed. How many of these is 1 mole? I need 22,4 liters. Each of these is 2, so I need 11 and a bit bottle of these full of gas equals a mole of gas. Okay, so if I line up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and a little one, that's 0.4 of a mole, or 0.4 of a liter, then I would have 1 mole of gas. It's very convenient that all gases occupy the same volume, which you haven't learnt about this year because we've skipped gases. But that's all you need to know about gases. That they all occupy, a mole of any gas occupies that at STP at standard temperature and pressure. And what is standard temperature and pressure? It's about room temperature and sea level. So room temperature is about 25 degrees, sea level is about whatever it is, in Pascal. I think it's about 200 kilopascals or something. But it's on your data sheet. On your data sheet, you'll find all those values. Any questions?
No.
Everyone happy? Ready to kill this in the exam? So we'll just change 1 or 2 of those things and then okay, I'm dying to use our new blackboard. The whole point of that new blackboard or green board is so that I can leave this for those people who need to write it down. So let's migrate to the green board there. Yeah, okay. Anyway, here this is
I've seen those shots in the book.
Okie doke. So the whole idea is I've always run out of board. So now we painted that black or green board so that we don't run out of board anymore. Okay. Question 7. Methane is used as an alternate fuel. The combustion of methane releases carbon dioxide and water. The balanced equation for this reaction is 1 methane plus 1 oxygen molecule goes to form 1 CO2 and 2 water. The activation energy for this reaction, in other words, it needs a little spark, is 172 kilojoules per mole. Is this reaction exothermic or endothermic? Okay, when you burn methane, now that's like your gas that comes out of the cooker. Does it give off heat or not? Okay, combustion sounds like it gives off heat. Heat out in Latin is exothermic. Exo out, thermos, heat. So this reaction is exo out, heat, thermal. Okay, so 7.1. Let's see if you can do this. Exothermic equals Greek for exo equals out, thermos equals heat, so this is a heat out reaction.
Is that how it works in relationship?
Now the way that you explain it is they say to you that it ends with plus 891 kilojoules per mole. That plus means, well actually sorry, that's wrong. Is that a divide sign there? No, that's a plus sign, eh? Okay, but it gives out that amount of heat. Now what is confusing for a moment there is the plus sign. Because exothermic reactions are always written with a negative sign. So if it's exothermic, it means it's lost minus heat. It loses heat. So I don't know if that's supposed to confuse you or where that came from, but just bear in mind, the way you know it's an exothermic reaction, if it says the loss of heat, we normally call delta H negative for exothermic. Delta H negative. Heat, the change of heat is negative, means it minus heat. It lost heat. Then they always give you a graph that looks like this. But this is more matric. This is your time, this is your energy. You go over a little activation hump, and then this is the energy of your reactants, And this is the energy of your product. The difference between them is called your delta H, and in this case it is 891. Have I lost you or not? So over time, this is the course of the reaction. Okay, please let me tell you a story. At time naught, we had only some reactants. They were given a spark called your activation energy. Energy of activation. But then once they got burning, they gave out heat. The difference between what they started with and what they ended with was 891 kilojoules per mole. And so that's why the graph has got that shape. And your delta H is negative because it's the final minus the initial, and the final is lower than the initial. So final minus initial, your initial is bigger, therefore your answer ends negative. So change of anything is final minus initial. Any questions? I know I'm packing a lot. But I know you guys are clever. I sometimes think teachers go too slowly. And you get bored. I don't think you're going to have that chance yet to get bored. Because you're going to say, sir is taking a whole term to do one section of work. No, sir is going to do 3 sections of work today. So, boredom is your least problem. Understanding it is important. Make sense? Okay, so heat is given out. Okay, now, so for 2 marks, why is it exothermic? Give a reason for your answer, because the final amount of energy, or the energy of product, so let's just try and explain it like this. Delta H equals final energy minus initial. And your final energy was near naught. Let's just say it ended at naught. And your initial energy must have then been 891. Okay, so let's just say that was naught. And that was 891. So it's minus 891. And that gave us an answer of minus 891 kilojoules per mole. Do you see how I work it out? Do you see how I work it out?
Now, yeah, they said combustion of methane. Now, and you said that means it's exothermic. So now, how are we going to know that it's endothermic? What word are they going to use?
If it's endothermic, your delta H will end up positive. So, an endothermic reaction looks like this. You start here, you go over your activation energy, and you end higher. Then your delta H, when you take final minus initial, will be a positive delta H. And that would be an endothermic. That would be exo. But to get to your question, in matric they will always tell you delta H is negative or positive. What I don't like about this question is the way they said it was plus 891. Because I would never do that. That's so confusing. I would always say it's minus 891 because it gives off. All agree? Okay. So somehow you've got to find a way of remembering. I remember it like this. If my bank balance goes negative, it's because I've given out money. That's how I kind of remember it. If my bank balance is negative, it's because I've given out money. And if my bank balance is positive, it's because I've taken in money. And that's how I remember it.
So, for instance, you just said now that if you had to like set up the paper, then you would have put minus 891. There would have been exothermic. But so also say now, explain now and everything. Then if they put your actually plus, isn't it endothermic or why isn't it endothermic?
Okay, I know that burning of gas cannot be endothermic. I know that.
Oh, so you basing on the what?
I'm basing it on any combustion reaction has to be exothermic. So that's the whole point of combustion, to give off heat. Okay, so that perhaps we must type the paper or something, but there's something wrong with that plus thing. Okay. And so, how do you explain it? Give a reason. Normally your reason will be because delta H is negative. That's normally your reason. But we can't say this here, so we have to say because that amount of energy is given off per mole. Explain why all chemical reactions need activation energy. Wow, we're doing a whole section here.
So, 7.1, can you also say because it's a combustion reaction?
I like that. Great, I would give you your marks. It's a combustion reaction, and combustion means gives out heat. You would get your 2 marks. Okay, what is the point of activation energy? So when it starts, if you've got a room full of gas and oxygen, what does it need before it all catches fire? A spark. Am I not right? You just need that little spark, then the exothermic provides the rest of the heat to keep the rest of the reaction going, because now it's hot already, right? So what is the purpose of activation energy? It's this. Here's your, let's get it on camera. Here is your methane. Here is your oxygen. They bump together, but they can't combine into CO2 and water because they need to bump hard enough, often enough, in the right configuration before a reaction can occur. It's like you can have 2 people in a room, girl and a boy. They're made for each other, but unless you get the right conditions, like you lock them in a lift for a power failure, then maybe they'll become best friends and marry and become friends for life. Sometimes you just need something more than them just bumping into each other for them to combine permanently, right? There's a sort of a reluctance of everyone to get together because we don't trust each other and for whatever reason. So if you can provide energy, something additional, just to get it started, then boom, the whole chemistry between the guy and the girl will occur. Often the activation energy is dating websites. Right, you just need that dating website to bring the 2 people together, and then now they're together, you brought them together, you've made it possible, the reaction occurred. So what was the question again? Explain why all chemical reactions need activation energy. Okay, it is this. Let's write it down. All reactions are happy. All products are happy. But how do we shake them out of their happy state to get them to a more happy state? We need some sort of energy to shake them apart or bring them together. So let's just say, so they don't want to do anything, they're happy. Activation energy shakes reactants apart or allows reactants to bump hard enough often enough in the right configuration for a successful intermediate union. Union. So if you want to chart the course of the relationship, it is A plus B goes to form A, B, C all together in some, and then they go to form C and D products. But at some stage, they're halfway between reactants and products. So there's all four are present at the same time. That's a very high energy state. That's where you need that energy to get them to the activated complex. We call that. So let's just say A, B, C, D together form the activated complex or combination of reactants and products. So on this graph, you would have A plus B, which is here, A plus B. Here you would have C plus D, but at the top we have A, B, C, and D as some intermediate activated complex. Okay, let's use an analogy. My wife and I are very comfortable. We've been married for 44, 45 years, whatever it is. We're comfortable. I was comfortable before I got married. My wife was comfortable before she got married. But while we were dating, we were hectic. I mean, it was every day I would go and visit her in Hillbrow, leave there at about 2 in the morning, drive home, go to university after that. It was high energy. Whew! Now I don't have to expend all that energy, she's just there. I'm just there, she doesn't have to expend any energy. So we went from a low energy state to a lower energy state. Marriage is a lower energy state. If in some circumstances, okay? But while you're dating, it's frantic. That's the activated complex, because you're not yet decided which way you're going to go. You're dating, you could go backwards, you could go forwards, but at this stage, you're pulling out all the stops to win the girl or the guy. Whew! Okay, so that's the activated complex. Now, some marriages end up a lot more work than people separate. Some marriages end up a lot less work together because you're sharing the tasks. You only have to wash dishes once every second night. Maybe you never make a bed. Maybe she does all the cooking. Maybe she looks after the baby. Maybe you go and do your job, but you were doing a job before you got married. So there's the analogy. Okay, but the dating is very high energy because you haven't yet decided if you are reactants or products yet. Okay, so let's just see if we've answered that question. Why do all reactions need a chemical reaction? Because the activated complex is always higher energy than the reactants or products. So 7.2, we could say the activated complex is always higher energy than either reactants or products. Make sense, everyone? Okay, so why is this not considered to be environmentally friendly? Which part of that reaction is not environmentally friendly?
Energy going down.
So the energy going up contributes to global warming? You wouldn't get a mark for that. Methane is being used up. Do you know that methane is contributes to global warming like 100 times more than CO2? So burning methane is actually environmentally friendly. You see, this paper got it wrong again. If you could burn methane and reduce CO2 just sucks in a little bit of heat, greenhouse gas. Methane is a terrible, terrible greenhouse gas. So actually this reaction is environmentally friendly. But what is the answer they're expecting of you? It's because it reduces the greenhouse gas, what called? Carbon dioxide. That's the answer they're looking for. Anything that produces CO2 is environmentally unfriendly. So that's the answer you must write. But if you explain to me that this reaction is very friendly because methane is a worse gas than CO2, boy, I have to give you a line. Because it's actually true.
But the earth rises not.
Yeah. So we know what the examiner's heading for. Do you guys know where methane comes from? Come on, someone must have followed. What's that girl, that little girl? What's her name? Thunberg. Greta Thunberg. Do you know her?
Oh, Greta Thunberg.
Yeah, that little Swedish Norwegian girl.
Oh, it is on that magazine.
On Time magazine. I think she's super. She's got a little bit of what do they call it? What do they call that? She's got some sort of syndrome that makes her very into herself.
Make a what?
It's a type of autism. But anyway, she's fantastic. She cares about the environment. Look, it's cows burping and farting that produces methane. So every meat eater on this planet is contributing towards methane. Cows burping and farting produces more methane than all the cars and coal factories. But coal factories contribute, cars contribute. So, why do cows fart methane? Because we feed them artificial feed. You know, in nature, giraffe and wildebeest don't fart and burp half as much as cows. So by cultivating a meat industry, we're actually contributing to global warming. Now, this is my personal opinion. I think this global warming is a lot of hoo-ha. On camera. I consider myself a scientist, and I consider global warming not something I would get excited about. And this is the reason I would say so. If you go back into the Earth's history, there were times in Earth's paleontological past, during the Carboniferous and other eras, when the carbon dioxide concentration was 10 times higher than what it is today. Today, our atmosphere is 0.5 or 0.5% CO2. That's a tiny amount. Of the air you're breathing out, it's either 0.5 or 0.05 is CO2. It's insignificant. And you know that it was 10 times higher in Earth's past history. So is that one reason you shouldn't be worried? And life existed. Okay, it wasn't human life. It wasn't dinosaurs. It was, there've been so many eras, great fish in this era. Do you know that 99% of all animals that have existed don't exist today? We are 1% of, if you go to the fossil record, there are 99 other animals for every one animal we have on Earth today. So, Earth will happily continue if we burn every single bit of coal on this planet. There may not be humans, but there'll be life. And humans are very adaptive. I think we could always adapt. But here's the problem, guys. Do you know that global warming will benefit Russia? Russia's cold. They will enjoy a nice warm climate. But here's the problem. We must all migrate to Russia then. Or Canada. Or the Arctic. And leave where we're living, where it gets too hot. That is the problem.
Are you going to live in the Arctic?
It'll be warm then. It'll be like South Africa today. Okay, the Arctic's got land under it, right? When all that ice melts, there's land there. The Antarctic, when it all melts, there's nothing there, it's just sea. So we could go and live in the Arctic. And in Alaska and in all those horrible places. But they'll now be nice and cozy warm. So what is the problem? People are not allowed to migrate. If we had a global world with no boundaries, we could all buzz off to where it's most comfortable. Look, there's 25 million Australians hogging Australia. 25 million. Why don't we send every person who wants a piece of land to Australia? Look at South Africa. When you get into a plane and you fly 3 minutes from Cape Town International, it's all just bare, barren land. Can't we share that? Why are we hogging land and saying, my land, my precious, don't you sit on my land? When there's land to be had everywhere. We must share the land. We must share the earth. We must migrate wherever we want to. Then it will all work out.
But so there's also social issues concerning the land.
Yeah, the social issues, we've got rich people owning, like 2 or 3 people own like 50% of America's wealth. That's the problem. And they own the land and they refuse to give it up. So we've got a cure for that. The guillotine. I'm saying land is different to cars. Because I'm saying there's a limited resource in cars, but there's unlimited land. I don't think a car equates to land. Well, in the sense that the government owns 30% of South Africa's land. Would it harm the government if the government gave the land, hey, anywhere where you find government land, which is 30% of South Africa, just go and squat there. Help yourself to 600 square meters. I guarantee you that when everyone is done squatting, it'll have gone from 30% government land to about 25% and everyone will be satisfied. Because each person squatting on a 600 square meters is still going to only take up a tiny bit of government land. This is ridiculous that people are born, live, and die without land. Ridiculous.
So why does the government even need land? Then the government, they're supposed to be watching us with the land.
So why doesn't the government give us the land?
Yeah, like why do they need the land?
I know, look at the police, they come and kick off squatters who's squatting on land that's got nothing there. But they've got a nice little shack, they built themselves a nice little shack and they come and kick them out. It's ridiculous. Those people had a place to live, they had. And here we celebrate the fact that these squatters are being kicked off. It's terrible. I think. It's not harming anybody that they're squatting there. Nobody. Because where they're squatting, there's nothing. It's the Cape by the beach there. So I'm saying, if the government should designate, you see those areas, but they must designate in every province, not just the Cape province, or everyone will just come down to the Cape. No, that every province must say, on the 1st of December, we've designated in every province areas of government land. On the 1st of December, you can go and pace out 600 meters, or the government can pace it out and say, if you don't own land, that's yours now permanently. And then you're not allowed to sell it, you're not allowed to do anything with it, it's yours, you're not allowed to, because people will soon try to exploit it and say, I want 10 plots. And anyone who owns land, you're not allowed to do that. So everyone will end up overnight with land. And no one will be harmed at all. But anyway, that's what I think. I am for the spreading of resources. Why should a person, as I say, be born, live and die without land? And all their life they're just eking out a living.
Now what about the facilities like toilets, plumbing, all that stuff?
Now that is your biggest problem, because people always want to live close to facilities, roads, transport, jobs. So that's why the squatters always squat near where there's already wires and plumbing and so on, right? Okay, but how hard would it be to run water to those people and set up a little electric power line to people and supply a train or a taxi route? Or don't do that, just let them squat near other squat settlements. Stop beating them off all the time. You see, you can either do this orderly yourself or you can just fight it, but I can tell you, in a year or two time, the government can't fight it anymore, and fantastic. I will celebrate that day. When they have to give up on keeping on throwing off people. That's my opinion. Any other opinions? Do you think I'm wrong? Sorry?
What did you say about the beach?
Now I'm saying, hello? I'm saying the beach is obviously no one owns a beach in South Africa. You're not allowed to. But if people built homes you can't build on a beach, but next to the beach, there you go. All the way up the west coast is bare, barren. But as you say, you've got to provide services. Now, services aren't that hard to provide. You can, on your roof, you can catch water. There's your water. You can have a solar panel to heat the water, and you can have a solar panel to provide basic electricity. And then you've got the problem of jobs. But we've got 20 million or more? 20 million people living on Sassa. It doesn't matter where they live. They could live in Namaqualand, in the middle of the Hamas there. And it makes no difference because they just get their 1,700 every month.
So exactly. So you can't give people free land. That's the thing. Like people, you need to charge people for land because then they get people in Sasset, they probably have jobs. And these people that are working, you tax them because the government needs money to facilitate hospitals and give people who cannot work. So if you're just giving people free land, then why are you taxing people? Then the people who's on tax are going to say, no, then why must I pay property tax? If people are out there squatting, paying nothing for land, paying nothing for electricity, then why am I doing it? Then I can use my money to buy stuff for my family, like food, or buy my $6,000 shoes that they want. Why am I paying tax?
Okay.
Then you stop paying tax, hospitals stop getting money, schools stop getting money, all our facilities are gone, education goes to the the schools are so low funded that you can't afford them. I'm just saying, sir, doing one big laws is a chain reaction. So yes, while we can give people squatter camps, then those people feel like, okay, now I don't need to work. And I'm not saying it's everybody, it's just, that's the general idea.
She's right, sir. She deserves another
Okay, so let me ask you this. Those 20 million people getting SASS already, right? They can live wherever they like. Am I right?
Yeah.
Do I, the taxpayer, feel I'm going to stop working because those 20 million are just sitting and lumbering around? Do I feel that way? No.
It is different because those people who get SASS are people who can't work, people who got pregnant, who didn't finish education, and people who already paid tax and who's now getting saving money back. That I'm fine, in the future I'll be fine paying my taxes if they're going to get the money. But I'm not going to pay tax. There are people squatting there, paying nothing for them.
What is, why must people have unemployment?
I'm paying for their facilities when they're not paying for mine. Where they don't have jobs, most of them, I'm not saying all of them, because they could be generalized.
Okay.
Where the government can use that money, that you say they must use these facilities to help pay for my child education, to help get better facilities, to help get better facilities at hospitals where hospitals can upgrade and maybe get to the same level as America or China or any other first-class country.
Okay, so let me ask you this. Let me ask you this question. Those people who turns down, or the red ants, or someone comes and pushes over their shack, and they're back to square one, and they keep on doing this, because they've done this for 20 years, right? Those people are never going to pay tax. Never. But if you gave them, as I suggest, 600 square meters, a basic house, they catch their own water, hot water, they can farm on their own land. Those people have got a better chance of becoming taxpayers, a much better chance of becoming taxpayers than continually bulldozing down their shacks. Because those people you talk about will never own land. They're condemned to be squatters forever. And as squatters, they're condemned to be pushed around and messed around. I am saying I'm creating a tax base by giving people land. Now those people have got something to lose. Your answer to it?
And what about that? They don't get any money.
I wanted to have, okay, we do the squatters land, for example. So now someone say, I'm just giving you a random place, says, okay, those people got free land, I'm gonna leave my house, I'm gonna go build a house there. I don't have to pay tax. I just have a squatter. You lose a taxpayer. And then people keep doing it. And then what you have, a lot of people not pay tax. A lot of people who say, okay, I'm getting free land, I'm getting free water, I'm getting free electricity. What's the point of a job? Let me go live there. I'm done.
Yeah, how are you going to... They need to grow their own food in my scenario. I said, put a solar panel in the roof. Solar panels are literally cheap. Okay, this is a poem.
So you know that I always thought if complains about it's like using too much responsibility. Yes, it's true, yes, sir. But if you think about it now, we have some like it's fright over us and everything. This is gonna cause us to put in solar panels and everything. And then in the end, if you think like properly and it will be worth the money because listen to this, and I say when I have a job during the day we use solar panels, that's your diesel, electricity, everything, and then you still must have the sun or whatever, that energy. And then maybe end up the job for night, or it's winter and then we use cold. So what? How much money is everything living in the same?
Where's the money gonna come from?
Exactly.
Yeah, all the you can I'm told to use
Okay, so better make your point. Just better make your point.
And like if you like give them to the house, some people that can spend cancer, if it's older, not bad, you pay them, so you have to get paid.
Okay, first of all, I'm not saying to foreigners now.
No, sir, I know, sir, I know, sir, but like, if not all squat, not on some aspects, just exactly. But they live on your sir. So it's gonna be solar and jungle. That's what I'm because no one will get it with us.
Okay, but then now, those foreigners are hurt by giving our local without land. Not hurting the foreign, and it's helping the local.
Yeah. So I have a question though. That's what was the simple about. So can you explain to me what is conjugate was?
Sorry?
Can you explain to me what is conjugate? What is that? Please, sir.
Are you talking about conjugate acids and bases?
Yes, sir.
Okay, we'll probably do that question. Okay, can we carry on with some physics? You guys are all so keen to become taxpayers. Isn't that wonderful?
No, sir, it's just the reality of
Sir, it's the
exactly, sir.
But you know how much tax
As much as you want to
You know that people who earn less than about 7,000 or 10,000 don't pay tax?
But so,
No, more than that. A month. Is it 4,000? Okay, 4,000. Okay, identify the conjugate. There's your word, acid-base. Conjugation in English is a word that joins two phrases like and or but. I think that's a conjugation, and or but. In physics, conjugate acid-base pairs are the two things that look similar on both sides. Now, of the two, that looks the most similar to this one or this one?
First one.
That one looks most similar to this one or this one?
The first one.
Obviously this one. And those look similar to each other. That's your conjugate acid-base pairs. Identify the conjugate acid-base pairs. Now, of the two, the one with more hydrogens is the acid, and then the one with less hydrogens is the base. So of the two, which one's got more hydrogens? So this is your acid, this is your base. Of these two, which has got more hydrogens? That's got 4, that's got 3, 4 beats 3, acid, base. Would you like a note on that? Conjugates, acid-base pairs look alike, differing by 1 H plus, 1 proton. The one with more protons is the acid, the other is conjugate base. Easy enough? Yeah. Let's give you another example. Okay, H2O plus H2O goes to form H3O plus OH minus. Which one's the conjugate acid-base pair?
What is it, sir?
So does that look similar to that? And that looks similar to that? Okay, so of the two, which is the acid? H3O must be the acid because that's got 2, so this must be the base. Of this, which is the acid and which is the base? H2O is an acid and OH is the base. You see how we can do it? But look how strange that is. How can water be an acid and a base? Well, Bronsted-Lowry it can be. Water can be both an acid and a base.
That is theory, sir.
Sorry?
That is theory, sir.
Detect a note of doubt about his theory. That's his theory, yeah. Okay, it's our theory for this year too. We will follow Bronsted-Lowry. Hey man, the guy gave a name to it, so it must be right. Okay, define the term ampholite.
What?
Anyone know what an amphibian is? Like a frog that lives in water and on?
Land.
So it is both this and that. So who wants to tell us what an amphiolite is? Yeah?
It's a substance that can act as an acid or base and can donate or accept.
So it is a substance
And so, just because we didn't go with I'm going
So can water act as an amphiolite?
Yes.
Acid and base. So water.
Yes.
Something over here can be an acid or a base. Any of these act as an acid or a base? Is this a base?
It's an acid.
Okay, it's an acid. Because it can donate a hydrogen. But could that either gain a hydrogen or lose a hydrogen? Yeah, so that's an amphiolite. It can go to form this SO4 2 minus plus a hydrogen. There it's acting as an acid. Or it can go HSO4 minus plus a hydrogen and go to form H2SO4, which is sulfuric acid. Here it's acting as a base. And it's doing it by an acid donates a proton, a base grabs a proton. So depending on what its situation is, it can either be an acid or a base. Any questions? Choose an amphiolite in above reaction. Okay, I've chosen one. Two marks. And then we come to 10 grams of impure sodium carbonate is added to 100 centimeter cube of a 0.2 decimeter cube sodium solution of hydrochloric acid. The acid is in excess. The equation for the reaction is that. Balance the equation above. Calculate the number of moles of hydrochloric acid. I'm going to ask you guys to take 8.3 and do a rice table. The same table as we did before for it. Okay, so 8.3. First balance it, then do a rice table. Ratio, initial, change, end. And your reaction is H2SO4 plus ammonia goes to form HSO4 and ammonia. So do a rice table for this.
So what question is that now, sir?
8.3. So all the questions will kind of fill a rice table nicely. So balance the reaction, calculate the number of moles of hydrochloric acid. You did that earlier in the period. Same way. It says the excess acid, so they know which one is the limiting reagent. So you know that the acid is in excess, therefore the sodium carbonate is going to be the limiting reagent. 8.3. This is all of 8.3. But you can answer it separately. But as you answer it separately, fill in your rice table. Okay, so I trust you can balance it, for example. Go ahead and balance it.
So, the values are different.
You put the 8.2 formula.
Oh, sorry. Hang on. Na2CO3. Thank you. No wonder you were confused.
Yeah. What? 8.2. What? Okay.
Sorry. There's just one that you have to do a rice table for.
You now will go. You will now go. What's the question?
So that was a long way.
Can you see so? So what's the materials for that?
You see, if I read them it this way, it fogs up. But this stuff is cellophane, it's supposed to stop fogging. So that I don't, so I can see better.
What did they speak to, sir?
Sorry?
What did they speak to?
The cellophane. It was free wrapping around a thing of pigs, clothes pigs. I think it might even still have the label on. 10 Rand 50. Whatever it cost.
Can you see that?
Yeah, no, I can see nicely. But if I took before, it used to fog up. So putting the cellophane on stops it fogging up so I can permanently see. Of course, if I had more money, I'd buy one of these that was made out of cellophane. Okay, if you stuck, just put up the hand and I'll try and help you.
Yeah. What? I'm still working on that. He said he was using our stick. Oh, I want to do this.
Okay, who can't balance that? Have you all balanced it? Yeah. You can't balance it. Okay, how many sodiums on the left? How many on the right? So what are you going to do? Are you going to do this? Are you going to put a 2 here? Where are we going to put our 2? In front. Now that sodium's are balanced. How many chlorines on the right now? How many on the left? So what are we going to do? Put a 2 there. Now we've got the sodiums and chlorines balanced. Let's count the hydrogens. How many hydrogens on the left? 2. How many on the right? 2. How many oxygens on the left? 3. How many on the right? 3. Okay. Now, who won't from this be able to write the numbers that are in front? What comes here for the sodium carbonate? 1. What comes to the hydrochloric acid? 2. What comes to this?
1.
See how easy that is? Now they ask you to calculate the initial values of some of them. Know the initial values of some of them. Do you know the initial values of these 3? What is the initial value of those 3? Sodium chloride, water, and CO2. We can already fill it in. What is it?
0.
You should. You should. You're right.
No. Why would I? Can you go away, please?
So the moles